Hi, folks, and welcome to Developer User Group. Big welcome to Chris Pitt, who's going to walk us through some game development magic. First, I just want to say thank you to Intellect and to Tasks on Demand for sponsoring us. We wouldn't be here without these sponsors. And then, of course, JetBrains, who's also got some prizes for us. So we will be looking at some good questions from the audience. And if you ask a really good question, you might just win yourself a JetBrains license. Those are pretty handy, and you can use it for pretty much all the JetBrains IDE products out there. Chris is a well-accomplished developer, author, craftsman, and baker. So a whole bunch of skills that he brings to the table. I'm very excited to hear about his latest game development knowledge that he's going to share with us about procedural content development, if I understand correctly. And it's all in this very fancy Godot engine, which is free to use, and it's works on all platforms. So you've got no excuses not to write a game tonight after this talk. Chris, thank you so much. Really appreciate you being here. I'm going to go off camera, but please take it away. It's all yours.
Thank you for the opportunity for having me. Yeah, hi, I'm Chris. I actually I am very new to game development, but one thing that I've learned a lot is that no matter what your background is or like where your skills lie, you can make games. There are tools that will cater to folks who are on the more traditionally I guess classified as creative side of things, if they want to focus on artwork and sound and have the code done in a no-code environment, or if you're more like me, and I presume most of you are going to be more like me in this regard, there are tools for generating art and music and putting that together. So whatever your skill set is, whatever your interests and talents are, you can make games. That's basically the message I want you to walk away with tonight. And I'm going to take you through the process of showing you some things about how I learned making games, a particularly good skill set that will help you if you want to get into it and you want to start producing lots and lots of games on your path to learning. That's procedural content generation. So yeah, let's jump into that. As I said, I come from a web dev background. I'm not sure if I said that. Maybe I just said that to Ewald. Yeah, I've been a web dev for a couple decades and worked in a whole bunch of different languages. My favorite language is actually Objective-C, which is weird because it's a weird language, but I like how clear it is. And this idea of clarity in the stuff that we make is actually quite important to me. It's one of the reasons why I like Godot so much, or Godot, however you prefer to pronounce that. I don't think there is a style guide for it. It's one of the things about Godot that drew me to it is the clarity that you can get while making games in it. But yeah, by day, I just do PHP and JavaScript stuff. I work for a company called Ringier. We make software for markets in Europe and Africa, so not a lot of local stuff. But chat to me if you care to know more about that. The first thing I did when I started out, because I was getting kind of bored of web dev, was I picked up a course. There's this guy who makes these courses on the internet. He's known as Heartbeast, but he has a website where he sells various courses. Some of them are for like pixel art. Some of them are for programming in Godot. And he does some really good YouTube content and free courses there as well. So if you're looking for sort of a concise, to the point, like video course, I highly recommend this one. I bought it, went through it. It's really, really, really good. And he builds quite naturally. So beginning with the basics and ramping up at a good pace to get to something that is fairly advanced. You can end up making like 4 or 5 games with the course. The first game I made was called Snake Catcher. It wasn't actually the first one because I made a few as part of that course, but this is the first one that I made that was completely separate from the course. I was just like, a few people in the universe who like it.
Oh, we seem to be having some technical difficulties.
point. I hope that's not the case. Go check it
Chris?
out if you feel like it. Yeah.
Chris, we seem to be having some technical difficulties with you pausing and resuming, just so you know.
My bad. It's probably the exchange that just switched over to batteries because my power just went out. Yeah.
Oh, okay.
Thank you, Escom. All I was saying was this was like the first game that I made separate from a course. It's a Minesweeper game. I used some free art for it. And it looks like this, right? It's just Minesweeper. If you've played that, if you're one of the few people in the universe that actually like the game, like me, then you might find it interesting. This took maybe about 2 or 3 days. But after I had made other like project-based things in Godot. And at the bottom, you'll see I used artwork by Kenny. There's another link to him further on in the slides, and some free music from a guy named One Man Symphony. Yeah, so I made that. And then I got this goal of like making a lot of small games quickly so that I could learn the skills around how to produce them. So the initial idea was I'll spend 2 weeks, make a game, like pick the idea, do something that I know I can ship in 2 weeks, take a couple of weeks break, and then repeat this process and try and do a game a month in a whole year. And I ended up doing that. I shipped 12 games. Some of them, like some months, I worked longer on the games. Some of them I joined a couple game jams and knocked out like 2 games in a month. It was a little bit unbalanced. It didn't quite work to schedule. But if you're going to try and become good at making games, this is a good approach I can recommend, of like picking a small project, building out a thing, shipping it in like a very tight time frame. And game jams are actually quite good for this. But making games can be hard. There are actually a lot of things that you need to do if you want to make a serious game, right? There's a difference, I guess, between making a small prototype to experiment with a new language or a new tech or try a new mechanic. Difference between that and then making a game that you can sell on Steam, as an example. You've got to end up wearing a whole lot of hats. There's, as I mentioned earlier, art and sound, there's programming, there's design and marketing, like the game design of like what makes a fun game, and then the marketing of like, okay, people aren't just going to flock to your game even if it's cool. You actually need to put it in front of people and make promotional material and do translation and all sorts of stuff. So there are lots of hats to wear. And sometimes because of why you're making the game, like if you've entered into a jam, you might not have a huge amount of time to do that. So what I can suggest to you is you remove one of the bottlenecks, which is when you're making a game, it needs to be compelling to get people to play it or to keep playing it. One of the ways that you do that is to have content that people can engage with. This is particularly important in games like Diablo, which we'll have a look at, where so much of the game is the content in the art and the story and progression and like cinematics. But games generally have this, right? Point and click adventures, puzzle games, they're all heavily based around the content that you need, and generating that content shouldn't really be a bottleneck for you if you're just starting out and if you have a short time frame. Procedural content generation, by the way, I'm going to just do PCG in the further slides because it's a little bit quicker to write. So procedural content generation helps to create emergent gameplay. If you've played a short game and put it down in like 20 minutes and never picked it up again, it's probably not a very engaging game. But then maybe you've played games like Rocket League or Counter-Strike or Valorant or Dota, where you're playing with other people and it just keeps on being fun, even though, well, I don't know so much about Dota because of the saltiness, but generally with multiplayer games, it just keeps on being fun because of emergent gameplay and interactions you have with people and the skills that you can learn playing against other people. Well, procedural content generation is similarly engaging because every run is new. Every experience is a new one and gets people continuing to play your games. But there are different levels of procedural content generation, and I'm going to explore just 2 of them so that you can kind of get a feel for the kinds of games you might want to make. There are partially generated ones with larger set pieces. An example of this, which we will look at, is Diablo II. And then there are completely generated games. And examples of this would be something like Minecraft or Oxygen Not Included. If you haven't played Oxygen Not Included, I highly recommend it because it's really good. So this is a screenshot from Diablo 2 Resurrected, which is like a recent remake of the original that was made like 20 years ago. And there are large sections of this game where you play with a top-down viewport, large sections which are completely randomly generated. I made this little graph to go in a book that actually the content of this talk is based on. And what I wanted to show was that like huge parts of this game, Diablo 2, are randomly generated. You go into the map, it's new every character. If you're playing multiplayer, every like time you join a server, that you get to these areas and they are completely different. You've got to re-explore them, rediscover where the points of interest are, where the entrance and the exits of it are. And the game itself is an open world game, but not at the same time, because there are these areas are always in sequence, but some playthroughs, certain optional areas are not there, or the way that they connect to each other is different. And so between those randomly, completely procedurally generated areas with like some handcrafted bits sprinkled in that are recognizable, there are these set pieces that are completely handcrafted. So where you start off in each major area, that like the quest hub, usually completely static. So you can know, okay, the vendor is always going to be there, and the story exposition guy is always going to be there, and the exit's usually like over there. You can kind of get familiar with these pieces, and the diamond shapes in this graph kind of indicate where those things are. So between all of this random generation, there are these very familiar, very predictable places. It's the kind of game where large parts of it are generated, but there are quite an extensive number of fixed pieces that are small and in predictable places that give you a little bit of familiarity. Contrast this with another game like Minecraft or like Oxygen Not Included, the latter being my favorite game of like all time, where you start in like a small area, but the entire world around you is randomly generated, and the resources therein are different each time you play. So some playthroughs are a lot harder than others, and the idea is to try and create stability in amongst all of this chaos created essentially by rolling the dice every time you go in. And so this is an example of a game that is fully procedural, in the sense that nothing that you are familiar with from playthrough to playthrough is the same. Okay, so what can we build with Godot? You can use any engine for this stuff. You can use plain old JavaScript for this stuff. You'll see that although I show Godot code and interface, the concepts aren't limited to that. It gives you a lot of tools that kind of do a lot of work for you, but you don't have to use Godot. You can use Unity. You can use Flash if you can get it to work. You can use JavaScript. It's up to you. We're going to look at code specifically from Godot. You can download it at this URL. It's free to use. It works on everything. You can even put it on an Android tablet or use a web version of it. So it's pretty good. Some key points. It uses a system of organizing code and interface similar to Flash or Unity, where you have these like things. Godot calls them nodes. They are visual representations of a kind of thing, like a window or a button or a player sprite or you get the point. And you can attach scripts to them. They're represented in a tree-like structure. Usually the scripts are attached to the top node, but you can attach scripts to anywhere. You can reuse the same script on multiple nodes. You can, there's like a class system for it. There are two languages for it. One is called GDScript and the other is called C#. The other is called C#. GDScript is like a Python superset language. So if you're familiar with Python and comfortable with it, I think it's the better of the two in terms of how it interacts with Godot. But you can use C# and they have parity in features. You just have to install a little bit more for C#, and I'm not sure about its portability if compiled from Godot because I haven't used it. I know that GDScript compiles well everywhere and works well everywhere, and I've got games on every platform from this thing without having to stress about how that actually happens. So I recommend GDScript. And another question that often pops up with game engines and picking which one is the best one and which of the rest suck is how good they are handling different sort of use cases. So is the engine particularly suited for 2D development? Is it particularly suited for 3D, or is it a mix of both? Unity is an example of one that has a lot of very strong tooling for 3D and for 2D, but the way that you make 2D games in Unity is kind of like 3D because the UI's language is kind of mixed in that sense. Still very good. Lots of brilliant games made with it. Not saying Unity sucks. I'm just describing the interface for it. Unreal, on the other hand, not super good for 2D games, very good for 3D games. You'll have lots of like web-based visual editors, or in fact, sort of more old school engines like Game Engine or Construct 3, which are very good for 2D games, kind of suck for 3D games. So Godot, I find, has a good mix of 2D and 3D capability. The 3D stuff has a very natural sort of interface to work with it. The 2D stuff as well, they're not the same interface, which kind of helps, I think. Enough waffle. This is what it looks like. You'll see on the left-hand side, there's like a tree structure with the main node and then all the other nodes. And where they have this little scroll next to them, they have a script attached to them. There's a little file system browser for managing things like images and sound, property inspector on the right. And then when you do the work of the thing, it happens in this middle pane. So at the top, you see there's a few tabs. The 2D one will show you a 2D interface for managing 2D games, like the elements, the nodes in that. 3D one will give you a 3D view for making 3D games. You can actually use both interfaces in the same game. I'm not really sure how that would work. Maybe thinking of something along the lines of Super Mario Odyssey, where large swaths of the game are 3D, but you kind of shift into a 2D space a lot for like mini game stuff. That's an example of why you would want something that's a very strong visual editor for 2D stuff, and for 3D stuff, Godot can do that for you. I don't know what Super Mario Odyssey was made in, but yeah. Okay, I want to show a few examples of how you use some of the core elements of Godot to be able to procedurally generate content and to make games in general. Pretty much from here on out, this is like the first 7-ish chapters of this book. I couldn't actually, I don't actually think that you could fit all of the content into a single succinct talk, because there's a lot of it in there. So I'm going to show you snippets which I think are interesting. But if you have questions, please ask them, or like message me. There's links at the end for how you can do that, or reach out to Ewald for how to message me as well and ask those questions, because I love talking about this nerdy nonsense and I love answering questions about it, but I can't fit the whole book in this talk. So here are the cliff notes. When working with nodes and scripts, you can randomize behavior. So to give you an example of what this might look like, if you wanted to design a forest that is randomly arranged, you want some trees here, some rocks there, a few patches of dirt here and there, this is how you might go about doing that. You could pick GDScript or C#, or my examples are going to be in GDScript. And you might lay out a grid of available cells. This is reminiscent of like older NES games where there's like grid-based movement and you move an entire grid square to get to grid cell to get to moving around the map. And you might lay it out like this. So, okay, here are my available cells. Now I want to put some trees some places and some rocks some other places. How could I do that? Well, you could dynamically create instances of things. If you come from programming languages like JavaScript or PHP or C#, you might be familiar with the idea of creating like a template of functionality, often called a class or a prototype, and then making instances of it, like copies of that template. So for example, if we were to bring this to the real world and use the language that I think this is based on, you could, if you wanted to make a sheet of music and distribute it to a whole bunch of musicians to play together at the same time. You would write that original sheet, that would be your class or your template. You'd stick that in the photocopier and you would print out instances of it. That's essentially what this does in programming. So Godot gives a few handy things that you can use to integrate between the nodes in the engine. One of them is that you can export a typed variable to the property inspector. So if I attach this script to a node, then I will have this doodad scene property in the property inspector. And when I click on the dropdown next to it, it will help me pick another scene that I can say, okay, this thing that I'm putting in this property inspector value, this references a different scene, so that when I come to the code that draws out that grid, I can say, take that scene that I've put in the property inspector and instantiate a new instance of it. I'm doing this in a loop, so I'm essentially going to make 25 of these doodad scene instances, and then I'm going to add them to another element that I've defined in the tree called items. So I'll add children to them. Each time this is run, I will add a new doodad scene instance as a child to the items container. Okay, very, very, very similar to what you would do if you were creating a dynamic interface in JavaScript, for example. But they're the methods you might use, or something like add child or new doodad scene. You know, add child, is that the method that you would use? But it's like a capital C and no underscore. Okay. What if you wanted to customize the behavior of each individual doodad scene then? If you wanted to make them pick what their own customization is going to be. There are a lot of methods in Godot for picking different kinds of random values. So randf, for example, is going to give you a float value between 0 and 1. You can do things like randi, which will give you an integer. You can do ranges of values. You might see more examples throughout the talk, but essentially it's giving you a random value that the engine is determining. Now, we'll talk a little bit more about how random that is later and how you seed that thing and useful ways you can seed it. But randf is like getting a random float, right? And here we can have a little bit of logic that says, pick a random float value. Usually it's going to be a transparent color because that's what most of these odds are. 7 out of 10 times, if you'll excuse my oversimplification of this, 7 out of 10 times, the color of this doodad scene is going to be transparent. 2 out of 10 times, it's going to be brown, and 1 out of 10 times, it's going to be dark green. And so if you run this code for each doodad that you've now added to your grid, you're going to get a little bit of randomization. The odds of this are, I mean, it's random, right? So they're not always going to be in the same place. It's not always going to be the same number of brown blocks or green blocks or transparent blocks. But here is maybe a subtle example of the weighting that we've added here. From 0 to 0.7 out of 1. That's the chance of it being a transparent block. Between 0.9 and 0.7, that's the chance of it being a brown block. And above 0.9 is the chance of it being a green block. It's a very, very simplistic way of creating randomization with very little code. Doesn't look like a naive way of randomizing stuff, but I think it's cool, right? And everything else that you build for procedural content generation builds on top of this idea. You get more advanced topics. I'm not going to go into things like noise generators and weighting and curves and all that kind of thing, because I don't think that's necessary for you to make good procedurally generated content. All you need is to be able to pick a random float or a random integer. Okay, Godot also has this thing called tile sets and terrains. You can pick an image from a free art website, something like this, and you can put it into a tile set in Godot. And then using the UI of Godot, which is actually for tiles and terrains, is actually kind of complicated. You should watch a video tutorial on that. I'll get back to this now. You can create sections of that tile map that you can then paint as a terrain onto a 2D scene in Godot. So you can create your maps just by like clicking, I want this tile, and drawing a whole line of it, or like selecting and drawing a rectangle of certain tiles. And there's all sorts of cool features in there, like randomly picking a tile of a set of tiles to draw, or auto tiling, where you can take your texture and you can say, okay, this piece over here in my texture is a top left corner, and this piece over here is a bottom right corner. And this piece over here is what you draw when you've got like a top border. And then you basically draw your whole shape, and it uses that logic that you've defined to then create connected textures so that you don't have to manually design your entire Mario level, for example. You can just draw ground, and where that meets a gap, it'll do like a nice corner, and where it meets a pipe, it'll draw like the base of the pipe. You can work that out with code and logic. But the terrain editor is actually super complicated to use if you've never used it before. So I highly recommend a video tutorial. Heartbeast has that on lockdown on YouTube. Actually, he has free tutorials about how to use that there. Now, if you take the randomization that you can put in scripts on nodes, and you take the tile set and terrain stuff, you can basically create a game. There's this game called Sokoban. Looks like this. Basically, you're this little man in the middle, and you can push crates onto dots. And when you do that, when you get all the crates onto dots, a door opens and you go to the next level. So you can probably imagine, like, from a tile set point of view, laying this out would get tedious if you didn't have a quick way to just like draw the map out and to like plonk down boxes, right? But you might not just want to use tile sets. Maybe you want to have the boxes and the player character as nodes, because then you can attach scripts to them to interact in certain ways. And you can actually mix these two concepts. I think I'll show you how to mix these two concepts in the next column. So I'll save that thinking for there. But this might be a good game for you to start with when you're creating something, because you can get the collision detection from Godot and its tools. You can attach scripts so that when the box lands on the dot, it registers as you've got a point against the level, and when you've got a certain number of points, yay, you win this level, you progress to the next one. It's a nice sort of starter project for you to do if you're getting into game dev, and it builds on the knowledge of nodes, scripts, randomization, and tile sets. Okay, at some point when you're making a game, even when you're making a procedural content generation game, whatever, you're going to run into this issue where you want to create certain palettes of certain like level sections and mix and match them together. An example of this is in Diablo 2. You might be in the middle of a completely procedurally generated area, but you will get to a section where there's like a cave that you can go into, and the design of that cave is not unique. It might be rotated a certain way, but you can always recognize it as a cave entrance. And that is done by creating these tiny set pieces. Maybe they do it just with a big multi-dimensional array in the level editor. Maybe they have a visual level editor. I want to suggest that a really quick and easy way that you can do this, not only in Godot, but in things like PHP or JavaScript, if you're more familiar with that, or even Unity and Unreal, if you want to use those tools instead, is to design your set pieces in pixel art, maybe even your level segments in pixel art. I will show you at the end, because we'll have a look through a game code base. I will show you how this idea can actually play out into helping you to generate truly procedurally content generated games, but in a way that gives you like a very stable base, not like a really random and broken experience. Okay, say you've got a level that you want to design, right? Now you can have this in a multi-dimensional array, but for argument's sake, I'm saying let's do a pixel art picture. The green things are trees, the gray things are stones or dirt or whatever, and the red thing is a pixel. How do we get this data out of the image and into like a designed level that you can walk around as a player? You might have some code like this. That continues really out of place over there. Sorry, that's triggering for me. You might have some code like this, and this actually looks similar to the code that you would do if you were using JavaScript or PHP to get image data. You get an image file via path. In Godot's case, you can actually have an exported property inspector thing that references the image file in the game. You loop by, you get the pixel data, right? What the RGB values are of each pixel. You loop by the width and the height, and then you can take the color and you can put it in a multi-dimensional array. I mean, it's essentially what that image file is, right? But this might be a little bit easier to work with if you bring it out of the proprietary image format into just a multi-dimensional array that you can then use methods on, right? So we loop by height and width, we get the pixel value. This actually gives us a hex value. And then we can once we have that hex value, we can loop over some preset arrays that like equate a hex value with a type of cell. So if you were designing a game if you were making a game that built levels, generated levels, where certain pixel values meant this is a tree and this is a rock, you could actually have a lookup table there saying that the color red is a player, the color green is a tree, the color gray is a block, or a rock, whatever. And then getting the pixel data, you could then create your multi-dimensional array, not referencing the pixel value, but referencing the type. So you can use an enum there or a constant that represents a certain data structure. Add them into your array, and you've got now your data that you can work with. Once you have that array, you can start to do interesting things with it, manipulating it algorithmically. This is like the simplest thing that you could do is a function that would flip it vertically or horizontally. I'll actually show you code that does this simple thing in order to make a really cool game. So it can be useful. It's good that you understand that you can do this once you have that array of pixel data. This is actually potentially how you would like code a server-side image flipping library kind of thing. I mean, you'd probably be able to do this just with command line utilities with stuff installed on the server. But if you had to code it from scratch, right, like a whiteboard test, you might be able to use an approach like this to flip the image or to like cut a small rectangular section out of it, you know, manipulate it algorithmically. So here we've got like this enum for what kind of flipping it is. Depending on what flipping is happening, we can either rearrange horizontally or rearrange vertically, and then return our like modified lookup table. And then depending on what's in there, like what enum values are in there, we can either do things like, draw a tile map out, and Godot actually like lets you, especially Godot 4, lets you do so many cool things programmatically with tile maps. So you can still do connected textures. You can visually represent which section of the image in your tile map is like a corner and a top border and a right border and a bottom border and a middle cell. And you can, so you can do that through the visual editor, but then programmatically you can say, okay, set the cell to being house. And depending on where that cell is connected to other cells that are house, it'll actually use the appropriate walls and corners that you have defined as like connected house textures, which is brilliant. And again, I'll show you an example of this in an actual game. It's just cool that you know that this is actually possible. I haven't seen this kind of scripting in a few other engines, but I'm not as experienced with other engines, so maybe they have it. This is just really cool to me. You can also define cells like in the previous examples when we were doing nodes and scripts and randomization, you saw code of like instantiating an instance of that blueprint, that template, that class. You can do it as well, but you can also do things like alter its position once it's added to the scene. So this code lets you go through that whole potentially modified array and then either draw tiles or cells, just depending on what the type of that cell is, what your enum values are. You should be starting to get an idea of like how you connect multi-dimensional arrays or even image data as a form of level editing to actually dynamically creating the levels on demand, which is cool. Okay, now let's talk a little bit about seeding, because procedural content generation depends a lot on randomization. And if it's not very good randomization, you're going to get samey levels. Oof, it's gotten really dark in here. I'm very glad for these lights. There are some games that have just completely random seeding, but most polished games that have a lot of procedural content generation have what's called a, I don't know if it's typically called this, but they have an explicit seeding system, one that you can potentially see the seed of and sometimes even change the seed of to create replayable experiences. I've got an example of this in Minecraft where when you create a new world in Minecraft, you actually see a seed input there that you can potentially put your own value in. Now, if you don't put a seed in there, Minecraft is going to create a random seed and it's going to generate a new experience, like a totally unique experience. So why would you want to put that seed in there? Well, if you've seen anything related to speed running of procedural content generation games, you'll know how important this is, because speedrunners will spend a lot of their time not just actually playing the game that they're speedrunning, but trying to find favorable seeds that they can have the fastest run in. So the fastest Minecraft speedrun is not actually with a completely unique map, because that would be impossible to have a level playing field for. The fastest Minecraft speedrun is a known seed that every speedrunner uses until another speedrunner finds a better seed, which is weird, but explicit seeding systems that allow you to change the seed basically let me start a new world and see, oh, this is really cool. I like this. There's some iron ore there, and there's some coal over there, and I've got like a nice little river going here. This is a really pleasant place for me to build my Minecraft house. Get that seed and give it to your friend, and then they have a nice place to build their house. The replayability is basically the recreatability of the procedural content is basically the use for this. I'll show you another way, another implication of this later. Just good to keep in mind. Now, what if we want to create the seeding? We can go down the Minecraft route where you just have like a random field and you can put anything in it. The seeds chosen there are often just random strings. But what works really well if you want to encourage people to share seeds is to have a way that you can get memorable words. Places in Europe for a long time have been trying to convert their postcode systems, for example, to systems of a small number of memorable words, right? Like what 3 words, I think, is the last system I heard of this, where the area, geographical area, down to like a 5-mile radius is 5 miles. What is that in kilometers? Who cares? It is like predictably called the same 3 words on official documentation. And when you give your postcode to someone, you're like, I'm in Green Hill Jigglypuff, for example, and then they can find you because they type this in a website and it tells them, oh, it's actually that geographical location. But you can remember what it is. You don't need to remember like an 8-digit alphanumeric code. So when you're making a seeding system, I encourage you to use this kind of thing. You can basically find word lists all over the internet that you can filter or theme or whatever. And Godot gives you tools to be able to use this stuff. You can, when you're using randomization in Godot, you can use like the kind of, you can think of them like global functions like randy or randef, or you can create an instance of a thing called a random number generator. When you create an instance of a random number generator, you can seed it explicitly. So here we've got a couple methods. The one at the bottom goes to a text file, loads it up to get all the words that are in it. They're separated by new line. And then the top function takes a random number generator and then a limit of words to get, like 3 words by default. And it will go through that entire list of words, randomly sort them, and then pull out 3 words. Now, we can use that in combination with other code that creates the more predictable numeric hash from an entire string. Godot actually has this. If you have like a string in GDScript, you can call a hash function on it and it will give you a numeric hash of that entire string. So even though you said your seed is Green Hill Jigglypuff, what did I call it? The hash for that will be a 32-bit numeric value that you can then use to seed the random number generator, because it takes an integer to seed it. Cool. So that's how you get from like a memorable textual explicit seed system to a numeric value that you can still put in to a random number generator that will give your friend exactly the same content generation starting point as you have had, so they can also build next to the river where there's iron there and coal there. Okay, we're going to look at a game now called Bouncy Cars. This was probably one of my favorite games to make. It took around 6 or 7 weeks to do. And it's definitely one of the most polished ones that I've done. So I'm going to hop out of here and show you, because I've got it loaded up here. Okay, let me just make that a lot smaller. So this is Bouncy Cars. What happens if I do that? So you can go into the game. Let me just move this up the way. Where do I put this? Like this floating bar is kind of stupid. Okay, I don't click on anything. Okay, so you go into this game. It's supposed to be a local co-op, or actually couch competitive, more like. It's like a racing game, right? You start a new game. You've got your 3-word random number generator seed over here. Is this hidden? No, okay. So it's picking 3 words from that list, but you can change the value that's there. Oh man, I hate this bar. You can change the value that's in this input to play a level that you know before. Player 1 picks a car, player 2 picks a car, and then you start your game. This is the controls for player 1 and the controls for player 2, just because my kids couldn't remember, and I basically made this for them. You'll see that I've got an arrow here telling me which way to go. So if I reverse a lot, it's going to say, hey, no, actually, the way that you want to go is over there. So the idea is that you either win the game by completing like 5 laps of each course, or being the only car that hasn't exploded. You'll see there's like a health bar on the left and on the right, and a whole lot of juicy screen shake every time you like crash into someone. And even if you crash into a wall, it still takes some of your health points off, because there's got to be some challenge to the game. So you basically have to like avoid the other player as much as possible and avoid the walls as much as possible if you want to win just by doing the laps. Otherwise, you can just cause them to crash into you or crash into the walls, so much so that they explode. Yeah, that's Bouncy Cars. Now, everything I've shown you for procedural content generation basically built up to how I did Bouncy Cars. There are a lot of really cool, interesting bits and pieces along the way that aren't just related to procedural content generation, specific challenges. And if there's a little bit more time or questions about it, I'm happy to go into that. But I just wanted to show you particularly the content sections with the art designed in pixel art. If I open up, how do I do this again? Show in File Manager. If I open up this segments PNG file with preview, it's really small because it's really small pixel art. I have defined these 6 segments in this art file. And every time someone starts a new game after they've picked a couple characters to work with, let me just expand this again, then the game creates a new map with 4 segments. You'll notice that they always meet in pixel 2 and 3 here, and in pixel 2 and 3 here, like all of their entrances and exits to the segment are at the same position. And so what I do is that I pick a random one and I put that at the top right, and I draw out each pixel using the tile maps and terrains and nodes. I'll talk a little bit about what the blue dots are, but the pink dot is player 1 starting position. The orange dot is player 2 potential starting position. But they're potential starting positions. I pick out a segment that I make as the top left one, and then I pick out another random segment that I want to have as the top right one. So I get its pixels, I flip them horizontally, and I place it in the top right. And then I pick out a segment that I want bottom left, so a random segment, and I flip it vertically. And then a segment for bottom right, I flip it horizontally and vertically. And because of those flippings and because of the consistent pixel positions, the entrances and exits of those segments always meet up together. Cool. So that's how I pick the segments and arrange the pixels and draw them from tiles to, from like pixels to actual tiles and cells in the game. Then I need to pick the direction that I go in. Is it clockwise or anti-clockwise? And I also need to have some kind of waypoint markers. So when I'm in the game and I'm like driving around and I like go in the wrong direction, that arrow that tells me where I should be driving is like a helper for my kids to know, okay, are they going in the right direction or the wrong direction? Must they turn around? Those arrows are created or helped along by having waypoint pixels here. So it's basically just a way to track which position to go to next. They're invisible nodes. But when each map is generated, I put these waypoints down, and then based on the initial like procedural generation metadata that I have, I picked whether it was clockwise or anti-clockwise. I pick a starting position for player 1, which is any pink pixel, and then I pick the nearest orange pixel to that selected one for player 2. And then I work out, are they facing clockwise or are they facing anti-clockwise? If they're facing, let's say they're facing clockwise, right? I fire a bullet off in the same direction, an invisible bullet. You don't actually see this, but I fire an invisible bullet off in the same direction that player 1 is facing, minus like 15 degrees. And if it misses any waypoint, it doesn't hit a waypoint, like it dies after like, I don't know, 200 pixels. I'm using simplified terms now to like try and get through this in the next 5 minutes. If it misses all the waypoints, I rotate it clockwise by like 2 degrees, fire it again. And this firing happens so quickly until it hits a waypoint that's like a collision detection zone. And then I know once it hits a waypoint, because my cars are driving in a clockwise manner. Is that clockwise for you? I don't know if my camera's flipped. Because my guys are driving in a clockwise manner, and I have hit a waypoint that is in front of my player, that's the first waypoint in the list. And then I fire at the same angle. If it misses something, I rotate clockwise again, another 2 degrees, until I like hit another waypoint. And this way, I circle around the track, hitting all those waypoints. And by the end of that, I have an ordered list of the waypoints the players need to drive through in order to get from the starting line all the way around to the ending line. And then I can say, if they collide with a waypoint that isn't the next one they were supposed to collide with, point them to the next one they were supposed to collide with until they hit that one, and then make the arrow disappear. And all of this calculation of firing bullets to work out the order that you move around the track happens within those first 3 seconds, but it has to take some time to calculate. And that's the reason that I ended up adding the starting clock. When you start a race, that countdown of 3, 2, 1, go, that is there primarily to give my little invisible bullet firing machine chance to go around the map to collect all the waypoints so that the players can know which direction to travel in. Whew, okay. There are actually a lot more techniques that I could talk about. Obviously, I don't have a super amount of time to do that. I basically went through chapters 1 through 7 in like 45 minutes here. But there are 4 games in total that you learn while you go through this book. And I think that's actually like one of the nicest things about the book is that like if you are engaged with it and you're building the stuff that you're reading about in the book, at the end you get like 4 games that you can like put on Android store or Apple store. And yeah, the next one along, I don't actually have time to talk a lot about mechanics, but I thought I would show it to you because it's super fun. It's a game I made for a game jam, and it's called Invasion. It doesn't have keyboard-based controls. It's actually got click to move, which has its whole set of challenges, right? Because you have to create a navigation map in a procedurally generated world. So like you have to, for game engines, typically, when you want a player to be able to move from point A to point B, oh, he caught me. When you want a player to be able to move from point A to point B, you have to create a traversable area so that the game engine can say, okay, here's my character. There's where I want to move to. Is there like a traversable way to get there? And then it calculates like pathfinding and collision detection, all those kinds of things. But when you're generating a dynamic map, how do you create that navigation zone? You've got to basically work in with all your procedural generation where the player now can't walk. You can't have them walk straight through a building, right? They have to walk around the buildings and like around the gravestones and trees and stuff. So you essentially have to like stitch together a navigation mesh then, which is a really cool trick to have to do. There's all kinds of other things like followers, like what this character is doing because they're following the player character, and like paths that you can, if you have like a linear point of movement, like with a tower defense game, you want all the people to roughly walk in the same sort of path. You might use like a path that you draw out in your fixed map. You draw out physically that you can see, and then you can tell them, okay, move along this path at X speed with a little bit of variation in position, so that they're all kind of like crowd around each other and move, but along the same predictable path. Well, you can do paths procedurally, just like I did the dots for waypoints in my Bouncy Cars map segments. You can do dots for points on a path and draw a path between them, and then dynamically create actors and say, follow this path. Potentially, I could have made AI for a single player experience for Bouncy Cars, where the player 2 is actually AI controlled and follows a path created by those waypoints around the map with some variation and collisions and all those kinds of things. I didn't know about paths when I made Bouncy Cars, so there we go. Yeah, there's interaction systems like you would have seen when I walked within range of this enemy or in range of the survivor. Interaction systems that you can create conversations, but how do you make those randomly generated, right? Like it depends on the plugin that you've got, whether you can create different avatars for different players, but then you have to deal with ideas of remembering what the player's avatar is. So when Invasion starts up and I generate the map for a new game, I go through everyone that I've spawned in the map, both friend and foe, and I assign them a random avatar, and then I have to remember that avatar, because when dialogue pops up for them, it's got to be the same person's face that's talking to you, right? This lady's face is the same every time I go back to this exit point where she berates me for not rescuing her first before I try and exit the level. So there's a whole bunch of stuff to consider about procedural content generation and how to make it like robust and cool. But it can actually save you time, because you're not sitting there creating new maps the whole time by hand. You're making small set pieces and putting them together in interesting and emergent ways to create new experiences every time someone plays. What else did I want to say? I think that's all in the slides. Oh, one more thing. If Godot is not your thing and you don't want to learn a new Python superset language and you prefer just to do this with JavaScript, I actually wrote a book a long time ago, which was really just a sneaky way of teaching JavaScript to people. But it's about making a 2D platformer in JavaScript. And what's cool about this is that all of the code examples of this are on a hosted JavaScript platform. I think this is like the most mind-blowing thing about JavaScript, is that it's so accessible. All of the code listings, they're in the book, but there's a URL there. And if you're in the PDF, you just click on the URL and it takes you to a code pen that has all of the JavaScript in. So for each chapter, you can see the game evolving as you learn more and more mechanics and more things about JavaScript and canvas-based art rendering and all of this stuff. The libraries that I use are a little bit dated, because this was like from 5 or 6 years ago, but the general concepts of collision detection and gravity and climbing stairs and walking up ramps and jumping and enemies and camera movement, all of that stuff still applies. So it's still a valuable read. And it's not a super thick book. It's not a super complicated book. The downside is you only have one game that you make from it. So if you're looking for something that will give you more games, I recommend this one. I think Ewout's actually supposed to be giving one of these copies away tonight or whatever. I'll let him talk more about that if that's still happening. But if you prefer something lighter, making games with JavaScript, maybe a language that you're more familiar with. That's it, I think. Are there questions? Does someone need to unmute people to be able to do that, or hands up or something?
I think the best is if people pop their questions into the chat.
Ah, okay, cool.
Yeah.
Oh, I haven't gone through the chat yet, so let me have a look. Nice waypoint mechanism, sneaky tricks. Yeah, it took so long to work out that thing. coming from web dev, it was like, whoa.
It's very impressive.
Yeah, I had a lot of fun making it. There are actually, if you, it's not actually here, but you can reach out if you want the link, or you can just, no, not tab space. What is that about? If you go to chris.itch.io, you can actually see the games that I've published to itch, and a lot of them are free. So like the Sitch game is actually super fun. Like it's a management sim game. I think it's like mechanically it's my favorite game, but Bouncy Cars is definitely up there, and Invasion. I made my first game in hey, what?
Don't forget Sprout.
Yeah, but I mean, Sprout's more of a tech demo than anything else. Like I had to cut off work on it after 5 weeks because I got into the situation of like, okay, now I need to make content for it. I don't want to have to do this, so I stopped working on it at that point.
Mm-hmm.
When did I make my first game? March last year, February, March, somewhere around there. In the last few months, I have, no, it must be older than that. Must be further back than that, Bruce. Slither Deep was sort of the second or third game that I made. I think this was actually 2 years ago now. Let me check here. Yeah, 2 years ago now, March, 2 years. So in the last few months, I've actually been doing a lot of, I've been doing less game dev because I've been doing a lot of restoration of retro consoles. And especially in the last couple of months preparing for Comic-Con, which is coming up the end of next week at CTICC. So yeah, my game dev stuff has sort of slowed down a little bit while I've been working on retro consoles and prep for that. Any other questions? Oh, cool. Good to hear, Sean. All right, that's me.
Chris, thank you so much. That was really cool stuff, man. Really appreciate you making time for us. If you want to give away one of your books, you can, because it's not a physical meetup. It's a little bit challenging to do that. So yeah, I don't know.
just get an address, bro. I'll post it off.
Well, you've got to pick someone from the questions list then that I think that was the most engaged. I'm thinking it's maybe Sean. Looks like he was throwing a lot of
it looks like
your
Sean.
way.
Sean, I'm going to put my, unless you want to reach out on Twitter for this, but otherwise I will put my email address in chat to you. And then if you can email me an address, I can send that to. Then I will send you a copy of that.
That's pretty awesome. I'm jealous.
Cool. Hey.
Chris, thank you very much. I definitely learned a lot. Intellect, Tarsus on Demand. Once again, thank you guys for sponsoring us and making this possible. And JetBrains with the JetBrains licenses. If there's any follow-up questions, you can find Chris on the internet, especially on Twitter. You can just, or if you struggle to find him, send me an email. I'll put you in touch with him. I'm kind of his PA, it seems. So we got to talk a little bit about salary, Chris. Just
exposure, bro.
Exposure. Oh yes, yeah. Thanks for that. Much appreciated. And that is it, everyone. Thank you so much for attending. 1 or 2 people that got JetBrains licenses, please email us. You've been sent direct messages. If you don't respond and don't let us know, then we can't give you the license, and that's just terrible, but shame on you. Chris, thanks a lot. Much appreciated. Everybody else, thank you for attending. We hope to see you here again next month.